So my name is Stephen Feuerstein. I'm the Oracle Developer Advocate for PL SQL. I rejoined Oracle back in March of 2014 after being away for 22 years from the company. Obviously not the technology. And I now have a team of people working with me, working for me. It's really nice. Chris, are you here? So listen, it's really great having people who are smarter than you and know much more about the Oracle database than you do working for you, because then when I'm stuck with a really hard SQL challenge, I don't learn the new features of SQL to solve my problem. I say, Chris, fix it. Or Kim. Is Kim still here? Anyway, so Chris and Connor McDonald have taken over for Tom Kite, and they're now running the Ask Tom site, the answer site. So in case you are still going there, it's those guys, and they're doing a great job. And I still do PL SQL and not much else. So I've got a blog, Twitter feed, YouTube, et cetera, et cetera, et cetera. Check it all out. And I think probably the best way to describe the title of this talk is more, let Oracle do the heavy lifting. If Oracle has built some stuff for you, you should take advantage of it. This is similar to Patrick Burrell's talk earlier, which is, get the most for your money out of the database. Fully leverage what we have to offer. Now, the main focus for my talk today is the compiler and what the PL SQL compiler gives you that you may not be aware of. But hopefully I'll also have time to at least throw in PL Scope, which is a really fantastic built-in code analysis tool that you can be leveraging and probably aren't now. So I don't live in the future, I live in the moment. But I have to put it here, I'm not going to talk about any future stuff, and if I do, I got the safe harbor in place. There are lots of resources for, you know what, I'm going to fix this because Bryn is right. Bryn Llewellyn is the PL SQL product manager, and it's not PL SQL developers, it's database developers. Oracle database developers. No, engineers, engineers, I'm not going there. I have a lot of respect for engineers. I do not call myself an engineer. And I'm sure some of you are. You might even be computer scientists. I'm not a computer scientist. So I'll just stick with developers, though I'll tell you a little funny story about engineers. So I got on a plane. It was really packed, and I was all the way in the back because I missed my earlier flight or something like that. Anyway, 27D, I had at least an aisle seat. I was very happy. So I get there. There's my seat. Right behind me, there's this guy holding his boarding pass that says 27F. And we look over, and there's this guy sitting in 27F. So we look at him. He looks at us, and I finally say, could you check your boarding pass? And he looks up, and he says, I'm a mechanical engineer. I think I know how to find my seat on an airplane. Seriously. He said this. We're like, oh, OK. And then after a little while, he took his boarding pass out of his pocket and looked up and said, I'm in 28. That was pretty good. But really, some of you, I'm sure, are engineers. I know I'm not, and I'm not going to try to pretend. So there are lots of resources for Oracle database developers and engineers. So we have a landing page for PL SQL. You can just start there if you're new to PL SQL, you want to find out about new resources. We have the good old PL SQL forums that are well handled by dozens of really great experts from around the world who are not Oracle employees answering all those questions for us. Thank you so much. Is anybody here active on the forums? Patrick, great. Thank you. Thank you so much. And probably the most important blog you could know about is the PL SQL and EBR blog by Bryn Llewellyn. So I think one of the great events for the PL SQL and EBR community really last year was that Bryn started a blog. Thank you, Bryn. And it's full of really great stuff, and you should check it out. He often basically is the front man for the developer organization, so he'll get people on the development team to write up some really great information about PL SQL and EBR, and then publish it through the blog. So please do bookmark this and read it regularly. And this is the place you can go for why use PL SQL, which Bryn presented on this morning. Hopefully a lot of you were there. And this is a great piece of information for you to have when you're facing off against Java developers or engineers in your organization. And they're saying, we want to do it all. We want to write all the SQL. What do you need anything in the database for besides bits and bytes that you pull in and out with single row processing? That will be a key weapon in your armor if you want to use military stuff. OK, Oracle Learning Library, big repository of content both on our database technologies and much more. There's the PL SQL Challenge, my website for taking quizzes. And hopefully some of you are doing that now, and more of you will. And today, actually, or yesterday, we just announced the early adapter version of our next generation quiz website, but unfortunately it looks like we lost the internet. There we go. It's the Dev Gym. So the Dev Gym is a place you can go to do workouts on Oracle database technology. And you can actually pick topics and we'll generate workouts that involve quizzes and videos and blog posts and so on. So check it out. You don't have to do the workouts. You can just exercise. You can compete. But it's a great way to deepen your knowledge about Oracle database. Ask Tom, hopefully you all know about. It is pretty much the #1 go-to site to get answers to hard questions on anything, apparently, not even Oracle related. We've had Microsoft Word questions lately and Star Wars questions. And they handle it all gracefully. And a little bit of sarcasm sometimes. But livesql.oracle.com. Anybody here use LiveSQL? So livesql.oracle.com is a 24/7, 12.1 database, soon to be 12.2 when it's in production. And it's a place you can go to just play around with the technology, but you don't have to do that. You're already in the technology. But what you can do is go there for the script repository. So there are hundreds of scripts. I've published about 110 myself of all my different PL SQL scripts and examples. And I'll use it during the talk, or I'll show you the scripts that you can use to back up what I'm presenting. And you can use it yourself. You can use it as your own private script repository. So you can post scripts up there. And if you're a consultant moving from location to location, you don't have to carry that floppy disk anymore. You know that floppy disk you carry around? You can now just go to LiveSQL, and there are your scripts. And then there are 2 sites from non-Oracle folks. OracleDeveloper.net, Adrian Billington, has been a great publisher of content detailed articles in every version of SQL and PL SQL up through 11G release 2. He kind of got caught up with children and hasn't gotten to 12C. And then, of course, Tim Hall's site, oraclebase.com. And he's been moving into the video world and producing a lot of videos. Anybody here do his .com for him? Anybody recorded .com? OK, so check out his videos. Fun guy, interesting content. So lots of resources. The reason I wanted to take the time to show you these things is that you only get so much out of these talks. In fact, my feeling about these talks is they're mostly infotainment. You can't absorb a lot of new information, real detailed knowledge about things. Will hopefully raise some flags in your head about things you can do. So the main thing is to know where to go afterwards to get access to stuff. OK, so let's talk about the PL SQL compiler. And we'll focus on 3 different areas: automatic, transparent optimization of code, compile time warnings framework to improve the quality and performance of your code, and conditional compilation. You actually get to tell the compiler which parts of your code you want to be compiled or not be compiled, and variations on that theme. So this was, let's see, do I talk about it here? Yep. So I remember a long time ago, I don't remember the year anymore, probably Bryn remembers when 10G came out. Do you remember when 10G came out?
2001 or so.
Long time ago, yeah. So we had a scare for a little while. Java was put into the database, and there was a concern among us in the community that, oh my God, are they going to throw out PL SQL and only do Java programming in the database, which would never have happened. But anyway, with 10G, it became really clear that Oracle was very committed to the PL SQL language, so they completely rewrote the compiler. Now, prior to 10G, the compiler compiled our code, turned it into partially compiled code at least, and then we could run that code, and it would tell us if we had mistakes in our syntax or referenced objects that don't exist, and so on. But with 10G, they basically pretty much brought the compiler up to a modern standard that you would expect in any programming language. So automatic optimization, compile time warnings, also known as lint checking. Everybody know what lint is? Probably not. You have a sweater, you get these little balls on the sweater that's lint, and you pull off the lint. You clean up your code. And then conditional compilation. So optimizing compiler. So now, unless you disable optimization, which is a really bad idea, and I doubt you'll ever do it, when the compiler compiles your code, first it makes sure that it will compile, and then it will possibly transform the code, change it in various ways to make it run faster. And the idea, of course, is that it doesn't change logically what your program does, it just changes the performance. So yes, in theory, your compile time increases, but I don't think you'll ever notice. You get to choose among 4 levels of optimization. So the default, and that's when the optimizer was first released in 10G, the default was to it remains 2. That was also the maximum at the time. You can turn off optimization entirely. You can reduce the amount of optimization with a level 1. That is the same as turning on debug. So debug mode is currently deprecated. If you want to compile your code under debug, you set the optimization level to 1. And then 2, at least until 11G, was the most aggressive in terms of doing the maximum possible number of transformations through your code to improve performance. Then in 11G, Oracle added another layer, or another level, level 3, that specifically focuses on allowing inlining of nested subprograms in your code. And I'll show you more about that. We have 6 people standing in the back. Do you like to stand for an hour? I don't. And there are a number of seats up here, so come on up. Feel free. Just scoot on in. You guys could scoot in. That's the polite thing to do, but we don't expect you to do that. Or you can have people climb over you. So the recommendation from the PL/SQL team is simple. Set your optimization level to 3. So it's going to come by default at 2. And that'll handle most of your optimization needs. But if you want to get the full benefits of optimization, set it up to level 3. This is obviously something your DBA would do. And then all your code will, by default, compile under level 3. Let's take a closer look. So one of the really great things about the optimizer is you really don't have to care about the details. You shouldn't care a whole lot about the details. It's a liberating experience. And I'll talk about some of the details or give you some examples to talk about what you don't have to care about anymore. So I'm not going to go through a lot of the details here, but basically the PL/SQL team identified what they would call freedoms, the kind of things they can change in your code that will not affect the logical outcome of the code and potentially improve performance. And then they implemented those. There's a white paper on the PL/SQL landing page. There's also additional information about the optimizer through Brin's PL/SQL and EBR blog. Okay? But this page will, I think, give you a better example. So suppose that the optimizer saw that you have the same computation a couple of times and nothing in between that's changing them. It'll declare a local variable, do the assignment once, do the expression once, assign it to the variable, and then use that temporary hidden variable in the code. Obviously, this is nothing you ever see. It just does it for you. So instead of doing that same expression or evaluating the expression multiple times, just once. Loop invariance. So let's see, I think I probably have a piece of code here, and I think, yeah, okay. Loop invariance. So there was a time a long time ago when you should have looked at code like this and said, oh my, why are you doing that? Why are you writing this kind of code? This is inefficient. And there are a couple of things that are pretty obvious here, but let me just point out the basic idea. I'm passing my name in. It's an in parameter. So can I change it inside my code? Right, it's essentially a constant. But inside my loop, I uppercase the name in over and over and over again. So prior to 10G, this could actually degrade the performance of your application. And it's doing this unnecessary work. You don't have to worry about it anymore. You could still say, that's a bad idea, and I'm going to move it out. I'm going to declare a constant in my program. I'm going to assign the upper to it and reference the constant here. But you don't have to do that. The optimizer will do it for you. So now you essentially can make a decision. Does it make more sense to leave it there from the standpoint of readability? That I'm reminding people that I'm doing an upper. Right? So, but you don't pay any kind of performance penalty. So the compiler will look at all the loop invariances inside the loop, pull them out, and make sure that they're executed just once. And then my personal absolute favorite, cursor for loops. So cursor for loops are probably just about one of the coolest features of PL/SQL. In fact, let's go to Live SQL. So here I am in Live SQL. Let's get rid of my bookmarks. Totally uninteresting. And I'm going to search for optimize. Automatic optimization of cursor for loop. So again, go to Live SQL, search, look around at the scripts, and certainly you can search for keywords that will help you find this stuff quite easily. So this is something I posted a few months ago. And then you can just run it and check things out. So let's run it. And I think it'll take a little while because we're showing you how slowly things can run when they're not optimized. But the basic idea, while that's finishing up, is quite simple. When you code a cursor for loop, when you write a cursor for loop and when it's executed, what you're really saying is, it's a high-level declarative statement to the compiler. You're saying, I want to go through every row fetched by this cursor and then execute whatever the body is. But I don't want to pay attention to the details. I don't want to have to open the cursor, do the fetch, figure out when to close the cursor, exit the loop, close the cursor. It's all done for us automatically. So I'm literally describing what I want, not how to get it done. Does that sound familiar? What does that describe? What did I just describe? SQL. That was the magic of SQL. How many of you have been using SQL for more than 20 years? It's been around a while, and it's still fresh as a daisy and getting better every day. But the amazing thing about SQL, and I know this because in 1987 and 88, what I was doing was standing up in front of crowds like this and saying, check this out, this is amazing, and I would press enter and run a SQL Plus script. And it would say select from, order by, and I'm like, whoa, and joins and whatever. The magic of SQL is that you're describing what you need, either the data set you need or the data you need to change. You're not writing a program to do it. The underlying engine figures out the best optimized way to satisfy your request. And that's what the cursor for loop is in a procedural language like PL SQL. It's a high-level declarative construct. Because of that, because I don't tell it how to do its job, it can optimize that code. And so what a cursor for loop does is automatically be optimized to run like a bulk collect. So it fetches 100 rows at a time instead of one. Now, those 100 rows are then, each one of those rows are processed within the loop. Again, you don't have to care about these details, but it's good to know that it happens. So if we go back to Live SQL and take a look at the results. So I've got a little timer in here using sys timestamp and showing differences. So what I'm doing is looking at 3 different ways of iterating through rows. One is cursor for loop. The other is I'm going to do it myself. I'm a control freak. I'm going to open the cursor. I'm going to set up a loop to fetch a row, exit when the cursor not found, and then close the cursor when done. I take control of my world. In this case, it's a really bad idea. Or you can use bulk collect, which there are a number of use cases for using even over a cursor for loop. Essentially, if your cursor for loop has non-query DML inserts, updates, deletes, you will want to explicitly convert to bulk collect and for all. But anyway, let's take a look at the results. So implicit cursor for loop took 5.8 seconds. Explicit took 5.7 seconds. Wait, that's about the same. And bulk fetch, notice, 0.38 seconds. A little bit faster. But wait a minute, I said that the implicit cursor for loop would run faster. So what's going on there? I didn't have optimization turned on. I turned off optimization. And I did that right here. I turned off optimization. Then I turned it back on. And now take a look. Implicit cursor for loop, 0.389 seconds. Row by row processing, 5.6 seconds. Okay? So that's probably the clearest demonstration that I can give you of the power of the optimizer. And the smart, and the smart way that the PL SQL team went about it, they didn't just do the standard set of optimizations that any language has. They looked at the specific nature of database programming and then optimized wherever they could from there. Yes?
How do you control the fetch size?
What was that?
How do you control the fetch size?
How do you control the fetch size? So I said it fetches 100 rows at a time. Can I modify that? You can modify that by switching to an explicit bulk collect fetch. You cannot modify the 100 row fetch size of the cursor for loop, hard-coded, or might not be hard-coded, but it's not something we can adjust. So for most situations, 100 rows, it gives you a nice big fat boost in performance, as you can see. If you're working with massive amounts of data, you might find that fetching 1,000 or 25,000 or 50,000 will give you much better performance. And that's, again, when you'd want to switch to that bulk collect and be able to specify a higher limit. But the bottom line is that for a lot of the normal use cases you're going to run into, just turning on optimization or leaving it on gives you this incredible boost in performance. Other questions? Okay. A question I often get, and Bryn's probably gotten it too, is there a way for us to see the compiled, the optimized code so that we can learn what you're doing so that we can write our own more optimized code, right, when we write our PL SQL code? And the answer is no, there's no way to see that. It's not even PL SQL when they're done with the optimization phase. And you shouldn't be asking that question. You shouldn't care. First of all, as I'm sure some of you are aware, from version to version, optimizations will change. So that's like too much information. It might be dangerous for you to know what the optimizations they do are, because then you end up trying to trick the compiler or be smarter than the compiler. I don't know about you, but I know that those guys and women on the PL SQL team are way smarter than me. So for me to try to outsmart anything they do is ridiculous. So you don't want to care about what the optimizer does. You just want to rely on it and focus on writing readable, maintainable code. So in 11G, Oracle added a new level 3 to optimize the inline or the execution of nested subprograms. You're not going to see usually a 100% order of magnitude kind of improvement, but you can see some nice incremental improvement in performance depending on how much you rely on nested subprograms and how often they're executed. So I think the main thing is to show you an example of inlining. Let's see. So nested subprograms, I think, is one of the most important techniques for you to write readable, maintainable code. How many of you do this now? You declare procedures and functions inside other procedures and functions. Pretty good. OK. And I know the rest of you actually do, but you just don't like to raise your hands. So just here's an example. Here's a procedure called intab. It basically does a select star from table in PL SQL. And most of this code, which is about 400 lines long, is relating to formatting your code. But if we go down to the bottom, in fact, of this long program, here's the main executable section. And I can read it to you. It's a table of contents, essentially. First, load the column information. Then construct and parse the query. Then do this. Then do that. You can literally just read the code. It tells its own story. Now, these could be separate subprograms declared at the package level or other schema level programs. But with nested subprograms, they only really make sense in that localized contents. They're very specific. And so you keep them inside there. So here they are. These are all procedures and functions defined within the higher level procedure. They're nested inside it. So that's the feature. And again, I strongly encourage you, if you don't do this now, to start using these nestings. Keep your executable sections really, really small so that they're not intimidating. They're easy to read. And the people who maintain your code will love you. But here's a problem. Every time you call a nested subprogram, there's a small amount of time spent, CPU cycles expended, to essentially look up the code for that nested subprogram and go run it. Okay? Now, in this kind of piece of code, I don't think you'd ever notice it. It's, let's say, doing 5 of these lookups and a few more higher up. But if you've got a loop, if you've got recursion, in which you're doing a lot of calls of these nested subprograms, the overhead, then you could start to see the overhead accumulate. Now, in that case, you might want to look at inlining. Again, the recommendation from the PL SQL team is just set it at 3. Let the compiler inline everything, and then you could actually accept that. I'll show you I can turn it off selectively if you want. So the basic idea is that when the code is compiled, if inlining is turned on, this call is replaced by the code. So essentially, the compiled code size increases, perhaps dramatically. There are literally copies of that nested subprogram put wherever the program is invoked. But then so the compile time is longer. You'll never notice it. The compiled code size can get bigger, but the runtime will be faster. Make sense? So if you want to, you can be selective about inlining. And again, I think the idea right now would be to turn on inlining and only use no to turn off the inlining. There apparently are some circumstances in which inlining can negate other optimizations that could occur in your code. So in theory, there are circumstances in which it could result in slower code. It's very unlikely. But in those kinds of cases, you can selectively turn off the inlining for specific invocations. OK, so that's my presentation on the optimizer. Any questions? So the question was, as you upgrade from one version to another, should you run basically compare explain plans between the versions to see if things have changed? I would say yes. And Chris, you can add nuance to that as much as you want. You should at least do some check on some of your key queries. But that has nothing to do with this optimizer. So you've got the cost-based optimizer, which optimizes SQL. You've got the PL SQL compiler optimizer that optimizes compiled PL SQL code completely distinct. Okay? In terms of you comparing how it was optimized how your PL SQL code was optimized in 10G versus 11G, I don't think there'd be any way. You can't look. There's no explain plan for the PL SQL optimizer. At best, you could run tests on performance. And you'd like to see that you're at least getting similar performance.
Is it the way
So I've got some old code. It was written years and years ago, maybe before there was even for all and bulk collect, which means a really long time ago. And you'd like to be able to compile it into the new version and have it magically transform it into using all the latest and greatest stuff. And the answer is, well, yes and no. So the cursor for loop will be optimized to similar levels of performance as bulk collect. But there's currently no optimization that will automatically transform your DML code, your transactional code like inserts, updates, and deletes, into for all-like behavior or performance. We can't do that safely. So the answer is sorry. No, you have to go through that code and make changes to it. And that's where the warnings come into play, because they will help guide you to the kind of changes you should be making. I'm not exactly sure what the question is, but if the question is, should I write code in anonymous blocks, declare begin and run scripts, right, the answer should be almost none of your code should be an anonymous block. You should write stored packages that contain all of your business logic. And then you have scripts that call those pieces of functionality. Absolutely, that is the way to go. Okay. So warnings that help you build better code. So the compiler, first of all, says, can you run this code? And if it compiles, then you're allowed to run the code. And it's done what it could to make it run faster automatically for you. It doesn't really address the fact that you might have written some really bad code in one way or another. Bad could mean you're not taking advantage of key features. Bad could mean it's entirely not maintainable. Bad could mean that you're going to get an error when you run that code. So that's what the warnings are for. So basically, the compile time warnings framework, when you turn it on, will give you feedback on how to improve the performance or maintainability and general quality of your code. So there's an Oracle document called Error Messages. The Error Messages manual. Check it out in the Doc Center. It has all the different errors, the different categories of errors. The PLS errors are PL SQL compilation errors. The PLWs are the PL SQL warnings. And you'll see there are dozens and dozens of warnings that have been defined, and hopefully we'll just keep adding more and more over time. Okay. So by default, unlike optimization, warnings are turned off. We don't bother you. I think we should keep them on actually by default, but I'll show you how you can just set that and have them on all the time. So there's essentially a PL SQL warning setting, either at a program level. You can actually say for a given procedure, I want to set my warnings level for that procedure. You can set it at a session level. And then when your code compiles, it'll be the warnings framework will engage and will give you feedback on your code. And you can simply say things like enable all, disable all, enable errors. So you can turn on, you can make every warning a hard compilation error if you're really strict about your code. That's what I do. No, that's not what I do. I get like 5,000 warnings after I compile my code. And I look through every one of them very carefully. And I agree, it's not so bad. You can say things like enable categories performance. You can enable an individual warning. You can even say that I want to treat a certain warning as an error. So there are certain warnings that I think are great candidates for, there's no way I ever want code that has that problem to go into production. And you can say literally, don't let this code compile with that warning. Let's take a look at some examples. And again, you will find lots of this on Live SQL. So if we go to Live SQL and look for warning, there must be more than that. OK, well, there's at least one script I put up there. It probably runs through a lot of the warnings, yes, or a few. OK, so essentially, for example, what I do in SQL Developer is I go into Preferences. I search for compile because I can never remember where it is. And here's the page, the PL SQL compiler page, and I can decide how I want to set my warnings. So right now I've enabled all warnings. And if I want to make them, if I want to get really serious and never ever be able to compile any of my code ever again, I set it to error, but I don't. Enable, and again, you can pick for the different categories. You can change your optimization level. So if I want to make sure that my optimization is always being at level 3, which I'm now going to do, I forgot about that. And then there's PL scope. Hopefully I'll come back to that today, depending on how fast I go. How many of you use PL SQL Developer here? No, wait a minute. How many of you use Toad? OK, put down your hands. How many of you use SQL Developer from Oracle as your primary development tool? As your primary development tool. Go ahead, SQL Developer, primary development tool. Okay, and PL SQL developer as your primary. Okay, a lot.
What about SQL Plus? Yeah.
How many of you use SQL Plus as your?
SQL CL, you mean?
How many of you use SQL CL? Okay, right. Well, I won't get into all of that. So the reason I asked about PL SQL developer is it's a very capable, very low-cost tool. It's not as cheap as SQL developer, but it's kind of close. And what I find interesting about PL SQL developer is that for years they have had warnings. I think it's their own warnings framework. Is it built on the PL SQL one now? I don't remember. Anyway, it's always on. And the only developers I've ever met in my multiple years in the world of PL SQL who insist on clean compiles are people who use PL SQL developer because they don't like seeing those warnings at the bottom. And in Toad and in SQL developer, it's not turned on by default. So I admire that greatly. OK, so here's an example. And I'll go through a few examples, but you get the idea. You should just start using it and exposing things in your code. So one of the really great analyses that the compiler will do is identify unreachable code. So in a program like this, you can probably tell pretty quickly, right, that especially because of my excellent documentation, that this line of code will never be executed, right? X is declared to be 10, it is 10, that executes not that. Obviously, in real programs, it's a little bit harder to find things like that. And you can be very surprised what you'll find in your code when you run it through the compile time warnings and you suddenly notice that 30 or 40 lines, entire subprograms are never possibly executed. It could be alarming. Often it's just a matter of saying, oh yeah, I don't use that anymore and pulling it out. Okay. Now I've got these names of files here, these PLW 6002. If you go to the Oracle Learning Library, you can search for the PL SQL Learning Library. You can download all of my scripts. But again, I've loaded most of the useful stuff onto Live SQL. That might be the best place to start. A couple more examples. So one of definitely my favorite from 11G was adding 6017. So something's going to raise an error. So when the warnings were first added in 10G, I was so excited. Now, finally, they'll tell me if I do this. And I was kind of disappointed when it turns out that it didn't. But they got to it in 11, and it was done in an interesting way. So the 6017 will basically tell you, and let's see if I'm still connected. I don't remember. So turn on warnings. Nope. So I got to reconnect. So basically when you, oh, that was fast. Thank you. Didn't expect that. Well, it doesn't always reconnect that quickly for me. All right, so I'm going to compile this code. I just made sure that all warnings were enabled, even though that was done automatically for me. So it compiled. I'll look at my compiler log. And it tells me two things. One is, Stephen, you forgot about your auth ID clause. So, no, it is there. That's not the right one. Let's clear this out. Let's do it again. And now I don't see it. Darn, I hate when I do that. Now I have to get the compiler view back. Who knows how to do that? Yeah, right? It's cute. So what the 6017 warning will tell you is, if you run this code, it's going to error out. So it'll detect, for example, that this is not going to fit. It'll detect that you've got a zero divide. It doesn't actually selectively point to the, well, it points to the lines. It doesn't tell you what the error will be, but it tells you you're dead. This is never going to work. That's kind of nice. And lots of other warnings. So the bottom line is that, and one of them was put in for Tom Kite. So when others than null, of course, is one of his famous diatribes around PL SQL. And it's just one of many forms of swallowing up exceptions. You can say when others then dbms output line error, but that allows your processing to continue. So the 6009 warning will give you a warning if your when others clause doesn't end in a raise or raise application error. You're not re-raising the error back out. Okay? Lots of things like that. Nice ways to enhance the quality of your code. So that's the 6017. Here's an example of treating a warning as a hard compile error. So 5005 is one of those that I think would qualify. Actually, the 6017 really does qualify for being an error, right? We have a runtime error. But I guess because it's not a compile time error, the compiler lets it go. The compile time warnings are warning you about PL SQL code, nothing to do with SQL. Okay? And obviously, we talk about it, and in many ways, these languages are very tightly integrated. But they still are two different languages with two different compilers and parsers and all that kind of stuff. Right, well, PL SQL uses the SQL parser. Okay. Right, so 5005. So 5005 is the error that says, I ran my function and it didn't return a value. Do you ever get that? I execute my code and it said function returned without value. I find that to be a really embarrassing error. Usually I'm busy, I'm writing some great code, I write a function, I figure it all out, and I'm done and I compile my code, it compiles fine. Or I didn't look at my warnings. Actually, that's what it is, I just don't look at my warnings. Maybe I should do that. Then I run my code, and it errors out because I forgot the return statement. Literally, it's a function without a return statement. The more classic case when you run into this is when you have multiple returns. Right? So if this is true, return that. If this is true, return that. And then, oh, no, there's a branch that doesn't. And of course, when you're testing your code, you don't test that branch for whatever reason, mostly because we're really bad at testing. And then it goes into production, and of course, the first thing that happens is the user forces the branch to go where it has never gone before. And you get an error. So the compiler, the warning will tell you that it found a branch of logic that resulted in not executing return. And again, you can flag that as one of the things you want to specify as an error. And then it will not allow that code to compile if it finds that problem. Okay. So compile time warnings, the first thing that I would do is go to the website, look at the documentation, and read through the warnings that Oracle has implemented. Partly, compile time warnings are about educating you more about the PL SQL language. For example, there are a number of warnings around using no copy. So if you have an out or in-out parameter, and you attach the no copy hint, you can often improve the performance of your program by avoiding copying in and copying out. Without going into the details, a lot of people don't even know about that feature. So what you'll get out of the warnings process is partly just saying, well, I never heard of that. Let's go find out about that one and start to use it in your code. Right? And then, of course, there's a whole QA side of this is going to raise an error. This exception handler is inadequate. It's missing the raise and so forth and so on. Right? And then with each new release of Oracle, check for additions. Brent, can you talk about 12.2 and compile time warnings? Can you say if there are any new ones coming out?
Can't remember.
OK.
You did invite me to speak, so I'll say something that you didn't say.
What if let's do an experiment. No. Sit down. See, he didn't sit down.
Turn warnings, disable warnings.
Yeah.
That's the mentality. So always compile, requesting warnings are an error. And then, in development time, you'll notice something that you really, really, really agree you want to do. And then you can disable that single one with a comment saying you're doing that.
So what he's saying is disable all, and then as you go through the compilation, error all, sorry, turn every warning into an error, and then go through the list of compile time errors and decide which of those you want to ignore. For example, you really don't want to be bothered about the auth ID clause. You don't use invoker rights. You don't care about putting an auth ID definer. So you can then not include that in your definition of what your compile time warning should be. Great idea. Yeah. OK, last, not least, but probably least likely to be used anyway, is conditional compilation. So the name tells it all. You get to conditionally, or you tell the compiler conditionally to include or exclude, not compile, chunks of your code. And you do that through various compiler directives. So for example, with conditional compilation, probably the classic use case, do you have a question? No, OK. Classic use case would be that we sell an application that runs in Oracle, and we support versions, unfortunately, 9 and 10 and 11 and 12. Now, it's hard to do that because there are different features in every version that you'd really love to take advantage of, but you don't want to end up with 4 copies of the file with different chunks of logic and some crazy commenting scheme. So what we often end up doing is least common denominator coding. I'd love to use for all, but I have to support Oracle 7. That's a really extreme example, but you get the idea. So with conditional compilation, you can literally say, if I'm on this version, use this, else this version, else, else. And in a single place in your code, have your maximum feature utilization across your different versions. You might want to run variations in your code between test, debug, production from the standpoint of both unit testing, exposing private modules for testing, and then hiding them back when you actually go production, or different levels of tracing and debugging in your code, all that kind of stuff. Bryn has written a white paper on conditional compilation. It's about 100 pages of detailed use case analysis, and I encourage you to check that out if some of these ideas look attractive to you. By the way, the title on this slide is not meant to imply that other features of PL/SQL are not finely nuanced. That's not really focused, is it? It's not just my eyes, is it? No, that's the wrong one. That's the right one. Is that better? What? Yes? Okay, well, anybody who wants to adjust, keep adjusting, go for it. So, again, I'll just run through this pretty quickly. I'll run out of time and also probably run out of your patience. The main idea is to give you a sense of what you can do. So essentially what you're looking at is $ syntax in PL/SQL. It's metacode inside your PL/SQL code. And so you have if statements. You can say if this certain condition is true, then include or exclude, or if it's not true, don't include it. You have $error, so you can actually force a compilation error if a certain condition is true. And I'll show you an example of that where you might want to do some essentially quality control in your code using conditional compilation. And then $$ are your different conditional compilation flags that you can use essentially as variables. They'll be constants that you can use in your if statements for your expressions. So let's run through some examples. And let's just go to the code to do it. Let's make sure that's turned back on. Okay. So suppose I've got all this different trace levels, and if debug is turned, so what I'm saying here, what I'm saying here is if debug is turned on and my trace level is at least 5, add that additional trace information. And then if commit is turned off, then go ahead and don't do the commit, comment disabled, else commit. So here's my session statement that says set my PL/SQL conditional compilation flags, turn on debug, set the trace level to 10, turn off commit. So I'm going to execute that statement. I'm going to compile that procedure. And then I can run my code. Now you have a very legitimate question to ask, which is, can I see what my code looks like that's going to be run? Because this supports all the different variations. The question is, what am I actually running? And in this case, yes, you can see that code. So there's a separate procedure package called dbms preprocessor print post process source. A mouthful. And then you can run that and find out what has been compiled, what will be executed. So you can see that I've got my trace and I've disabled commit, and you see a lot of white space around here. So the PL/SQL team was really careful to preserve the original line numbers and locations in the line of your code. This matches exactly what you see up here if I take out all this stuff and so on and so forth. So does anybody know why they do that? Why we maintain that white space like that? Yeah, so when an error occurs and when you're doing execution call stacks and you see line numbers for your code, you can go back to your original source, which has all those $ in it, and it's still the right line.
Are OE, bug, or commit off, are those reserved words or just any words you create?
Just made them up. So those are my flags. I just made them up right there. I can even never use these in my code, and it wouldn't, complain about it. That's it. You just make them up yourself. There are a set of flags that come with conditional compilation. So and I'll cover some of those soon. But you can make up whatever you need for your own application. They can only be Booleans or integer values, and you can also use packaged constants as well. You can have your own packages with constants in it. But they have to be static constants, which essentially means no matter how many different people execute that package or reference the package, the value of the constant is always the same. if your constant is being given the value of sequence.nextval, that is not a static constant, because everybody who references that package, every session that references the package, gets a different value. So what I'm going to do now is set my PL/SQL CC flags just to turn off debug, and by implication, that'll be null, that'll be null. So I do this, alter my session, compile my code, and now I'm going to print out my code again. And now you can see that it looks quite different. Right? So the commit's in, DBMS output is gone. So that shows you the essential nature of conditional compilation. You get to decide what the compiler actually compiles. So when you compile the code, the warning settings are associated with that program unit. Whatever's current in the session is recorded with the program unit. The next time you recompile the code, unless you say alter, compile, and is it reset? Reuse settings, thank you. If you say reuse settings when you recompile, it'll keep whatever your settings are for that program unit, no matter what the session settings are. But what I did here was simply say recompile. So it used the current session settings. And those are now stored with the program unit. So when you do the alter session commit, it has no impact whatever on your currently compiled code.
Remember where they're being used for you to run the alter statement. If you're just having 20 procedures in hand.
So you're saying if I do an alter session, then I have to remember where did I use that flag in which subprogram so I know to recompile those? Sure. So conditional compilation is not something you're going to use in any way casually. In fact, most people will not. How many of you have used conditional compilation? Use it in your code? Excellent. It's a good number. We see the numbers going up every time we do a conference. But relatively few. It's always going to be relatively few. It's a fairly specialized kind of feature. And you should not be in a situation where you're saying, oh, where did I use conditional compilation again? But obviously, it's not that hard to search your code and find it either. You don't have a lot of $ showing up in your code. And Bryn, yes?
I'll just say one thing very briefly. The work that I find most compelling is in comparison exercise, performance testing, all the stuff that never makes it into production. Your research, if you want to compare two things, it's a very elegant way.
And I think what would be great, Bryn, is if you publish on your blog showing people how you use conditional compilation to build these really powerful, expressive, and concise analysis scripts. That'd be a great boon to the community. Don't you think? Doesn't that sound great? He has so many really excellent scripts that he's written over the years that I get to see, but you don't get to see, and I want to share that love with all of you. So, error directive.
I gift them to you.
You would not want me to publish your stuff. We know this, Bryn. We know this. Okay, so here's an example of how you might want to use conditional compilation for QA, quality control in your code. Suppose there's a program that has to be compiled with full optimization or it runs really, really slowly. So optimization at level 1 or 0 is simply not an option. And you want to make sure you're not going to trust anybody to make sure that the default level is set to 2 or 3. So you can literally ask, here's an example of a predefined conditional flag, CC flag, PL/SQL optimized level. And if the optimized level is less than 2, you'll actually stop the program from compiling. So that's just one example. You might come up with some other ideas yourselves.
If you haven't defined that variable, what will happen?
Well, that variable you don't get to define it. That's built in.
PL/SQL optimized.
Yes. So essentially all the columns of the PL/SQL compile object. There's a view that contains all of your compile time settings. And these are all the built-in values that you can get out of that table. So the code type, whether it's native or interpreted, what your warning settings are, your conditional compilation flag settings for that program unit. So these are all built in. If you reference a conditional compilation flag that is your own, or that is otherwise just nonsense, you had a typo, it evaluates to null. And when you do your conditional compilation logic, your conditional statements, you want to make sure that the default state, which is nothing's been set, is your production state, and it works like you want it in production. In other words, you shouldn't design your code so that a conditional compilation flag should be set in a certain way to get your production behavior, because then you might run into problems where it's not been set. Every version of the database that supports conditional compilation, which is pretty much everything these days, has a new package, or a package called DBMS DB version. So this has a set of constants that have been defined to give you absolute and relative version information. So if you ever want to find out what your version and release of your database is, DBMS DB version has that information in it, and it has a number of relative ones as well. So here what I'm saying is that if the version is less than or equal to 10.1, then use some logic that essentially gets rid of all the gaps in my collection. Otherwise, use indices of, which is added in 10.2. So that's how you write the code for different versions of the database. All right, I am out of time. So conditional compilation, very powerful feature. Not that hard to learn. It's something you have to be very careful about how you implement in your code. Do check out Bryn's white paper about it. To sum up entirely, and I'm not going to get to PL scope, optimizer, just enjoy the default or get it up to 3. But even at 2, you're still doing really well. Don't worry about the details. Don't worry about, for example, looking at your code and saying, oh, I'm doing an uppercase every time I execute my loop. You don't have to worry about those things anymore. You might still decide you want to take it out. You don't have to. Compile time warnings, turn them on. Take a look. Go Bryn's route and make them all errors and spend a lot of time sorting out your code and figure out what you want to keep and not keep. But give it a try, and at least, at a minimum, read the doc. Look at the warnings that Oracle has defined, and especially as every new version comes out. Conditional compilation, the main thing is to be aware of it so that if one of those use cases come up, so hopefully a light bulb will go off in your head in the shape of a $sign, but it'll be conditional compilation, and you'll go check it out. All right, well, I'm right at the end, but let's see if we have any questions for a moment or two. All right, thanks for joining me. Have a great Kscope. Thank you.